We're going to put together the concepts of pounds per acre and harvest efficiency as a step towards calculating stocking rate or carrying capacity for the property. Let's look at 3 example pastures and estimate pounds per acre for each of these pastures. The first is a sub-irrigated pasture. Now, this time when we estimate pounds per acre, we're going to think about total annual forage production. So think about it this way. If we didn't turn a single grazing animal in there, we went out at the end of the growing season and looked at the forage production in each of these pastures, what would be our estimate of total annual forage production? Remember, we're estimating air-dried forage, what the animal will eat, taken to the height that an animal's lips can physically take it. So let's talk about this sub-irrigated pasture. This is a 100-acre pasture, sub-irrigated. At the end of the growing season, if we looked at this sub-irrigated pasture, hadn't been grazed at all throughout the growing season, how many pounds per acre might be there right before we get a killing frost? For this example, we're going to assume that this is 3,000 pounds per acre, so about 1.5 tons per acre of feed. This second one is a more typical rangeland site for eastern Wyoming. 1,000 acres, mixed grasses, tall, cool season grasses, lower growing, warm season, some other plants like threadleaf sedge mixed in with some shrubs. Let's say we walked out and estimated what's in this pasture at the end of the growing season. Could be anywhere from 600 pounds per acre up to 1,500 to 2,000 pounds per acre. A more typical site in this part of the world might be 1,200 or 1,000 pounds per acre. To make the math simple, let's use 1,000 pounds per acre for this site. All right, this might be a more rugged pasture, larger area, probably shallower soils, probably poorer plant production. Here's a 5,000 acre pasture, only a few watering points in this pasture, wider plant spacings, more bunch grasses, more dominance of shrubs and other types of plant material. At the end of the growing season, if we didn't have any livestock in there for the entire growing season, look at it right before killing frost, let's say we'd estimate there's 500 pounds per acre in this pasture. All right, so now we've taken an estimate of total annual forage production for each of these 3 pastures. Your pastures are probably going to be different. We're just using these as an example. The next question is, what proportion of this feed are we actually going to put in the belly of our grazing animals? We called that harvest efficiency. There's a chart linked on this page that will give you some guidelines as starting points. But you also have to use your knowledge of the place, how you're going to graze it, water distribution, terrain features, all these things to make your own guesstimates or adjustments with that chart. So let's start with this first one. We said it's 100 acres. It's well watered. Let's say we're going to graze it in a way where we put a lot of animals in there and they're only going to be in there for a shorter period of time. Let's say within 15 days we're going to have everything we want to have eaten out of this pasture will be eaten. So as you look at that chart, we're going to use the irrigated column to represent this sub-irrigated pasture. You can see if we use a 15-day graze period, the recommended harvest efficiency for this site would be 65%. Now I like the fact that it's well watered, it's even rolling terrain or almost completely flat. Livestock distribution throughout the pasture is not really going to be an issue. We're going to get just as even grazing at this corner as we will right out in here. So I'm going to go ahead and push that up a little bit. Instead of 65, I'm going to use 70% harvest efficiency. Let's talk about this second pasture. A little more terrain features. Only 2 watering points for a 1,000-acre pasture. If this were in square miles, it'd be a little less than 2 square miles. So this might be a mile this way and 2 miles that way, even though I haven't drawn it to scale. With only 2 watering points, do you think there's going to be different grazing around these watering points and within a 1/4 mile to a 1/2 mile of these watering points than there will be out in this corner? You bet. We're going to have some differences in the way this is used. Let's say we're visiting with the rancher that's going to graze this, and he says, I'm going to put cows in there, and they're going to be in there for at least a month, probably more like 45 days. So looking at your chart, we're talking about native rangeland. We're talking about a grazing period in excess of 30 days. Harvest efficiency, according to the chart, is going to be somewhere around 25%. Okay. If I was comfortable using this pasture a little more severely, grazing these plants a little harder than most might like them, I might push that up to 30%. Let's use a 30% harvest efficiency for this pasture. On this last pasture, good sized pasture, 4 watering points with a large zone that has almost no water to it. Terrain features are going to be more significant on this pasture. There's some steeper canyons, there's some areas that are inaccessible to livestock. And again, we're going to put animals in here. This might be a pasture where grazing cattle stay for 4 or 5 months. Okay? So as you look at your chart, native rangeland, longer than 30-day graze period. 25% is the recommended harvest efficiency. Knowing that I've got areas that are significantly underwatered and I've got some terrain features, I'm going to lower that down to 20% harvest efficiency.